Hello, my name is Magdalena Rajczakowska and I'm a postdoctoral researcher at Building Materials Group in Luleå University of Technology. My main research area is autogenous self-healing concrete. So you might wonder, what is self-healing? Imagine a material that can repair its own damage without any human intervention, just in a similar way as our skin can repair and heal the wounds after a cut. So in concrete, and this can be any kind of concrete, not any special one, can be a traditional one, there are certain ingredients that help to trigger internal chemical reactions that lead to formation of healing products inside the crack and ultimately sealing it from the inside. In my research project, we studied the mechanism behind this process, but also we looked into potential boosters, so special ingredients like certain types of fibers that could enhance the efficiency of the process. From the industrial perspective, self-healing concrete could drastically reduce the long-term maintenance of the cracked structures. So we're talking about the cost of such repair works, but also disturbances that they cause. And most importantly, looking from the sustainability point of view, we wouldn't need to use more material and consume more resources to fix the structures, which is important when it comes to lowering the CO2 emissions of the construction industry. Looking forward, I see a lot more research going in the self-healing concrete. For sure, there's a lot of laboratory work going, and it will continue when we will get to test new binder systems and new admixtures. But what is important is to bring those tests to the field, to test it in real world conditions, to be able to prove that this concept can work and can be used by the industry. Another aspect that is important is to develop computational methods to predict and simulate the self-healing process, so we wouldn't need to have more experiments that cost a lot of money. What I'm most excited about is the idea of truly smart cementitious materials. So materials that integrate self-healing, but also with other properties like self-sensing or self-cleaning, radiation shielding. So for instance, imagine a material that could first detect the damage and prevent further growth of the crack. So when the crack is very small, it's easy to heal it. I think this, plus being able to simulate and truly understand and control those processes, would lead to a future when we can have smart concrete on demand for specific application and specific conditions, which would make it a lot easier for the construction industry to function. I am very grateful to SBUF for co-funding my doctoral project on self-healing concrete. I think what is particularly important about SBUF is that it doesn't just fund projects that produce scientific publications. It funds projects that are connected to real industry needs and that solve construction challenges that we have right now. I hope to see myself in Swedish academia in the future, and I really hope that I will be able to collaborate with SBUF on my other research ideas. If you are interested in my research on self-healing, but also on other topics, I invite you to read my scientific publications. You can find them also at LTU website, and also the reports from my doctoral project on SBUF website. And I wanted to highly recommend checking out Building Materials Group website and LinkedIn profile, because we are having a lot of fascinating projects right now we're working on.